Namaste. You know already, basically there are three types of mirrors. One is a plain mirror, which is used at your home, and one more is concave mirror, which is used by the dentists. And even one more is the convex mirror, which is used in vehicles to see the backside portion of the traffic. Okay, these are the three types of the mirrors, as you know basically. So using these things, today let's discuss the sign conventions used for reflection by the spherical mirrors. I will show you a simple component here. You know this is called as a watch glass, right? So in the watch glass, this portion, okay, this inward portion, so this is called as a concave shape, and this external part, this is called as a convex type of a shape. Okay, by this way only you can easily understand what do you mean by convex shape and concave type of a shape. So same rule if you apply in case of a mirrors also. So in case of mirror, three important sign conventions will come, and using those sign conventions, we can easily solve any type of a numericals. Okay, and today let's discuss what are those sign conventions. Before that discussion, so observe this diagram properly. As you already know, this shape is called as a concave shape, and this mirror is called as a concave type of a mirror. So in the exact middle position of the mirror, this point is called as pole. P is indicating the pole. And the line which is passing through this pole, this line is called as a principal axis. The main axis it is called principal axis. And this entire middle portion, okay, if you extend one circle, you can imagine one circle here, okay, the exact middle position, this is called as a center of curvature. This C is indicating center of curvature of a spherical surface. At this point it is called as a focus point. Principal focus it is called as, or you can also say it as focus. It is indicated by the letter capital F. Okay, and generally you know that these concave type of mirrors, they are going to converge the light rays at a certain point. Okay, and that location already you know, this is called as a focus point. And also remember, the distance between this pole to the focus point is called as a focal length. This is indicated by small letter of F. Okay, this F is indicating the focal length, the distance from pole to the focus. Okay, and the distance between this pole to the center of curvature is called radius of curvature. Okay, in circle also we use the term radius, right? Like this time, the distance from P to C, or the distance between the pole to the center of curvature is called as a radius of curvature. So these are the important components that we are using. And this shaded thing, okay, the shaded backside portion of a concave mirror, this is indicating that it is mirror, or else it will become as a lens. Okay, so now let's go for the sign conventions. The first sign convention rule says that all the distances are measured from the pole of a spherical mirror. That means whatever the distance is, suppose if it is a concave type of a shape, imagine it as a concave type of mirror. The distance from this object to that window, there is one window at that portion, the distance should be measured from this pole, not from that side. The first rule says that all the distances should be measured from the pole only. This is the first rule. You are not supposed to measure the distance from that object. Measure the distance from any image point. You should always measure the distance from the pole. This is the first rule. And second rule says that the distance is measured in the direction of incident light. The distances measured in the direction of incident light are taken as positive, while the distances measured in the direction opposite to the direction of incident light are taken as negative. Very simply I will tell you. Observe here, all the distances should be measured from the pole. Already you know this point. Okay, if the light is coming in this way, okay, and the image formation is going to take place inside the mirror or in front of the mirror, it depends upon situation. Okay, the distance is measured in the direction of the light. You are measuring in the direction of the light. Observe here, suppose if it is a concave mirror, if you are measuring in the direction from this pole to this distance, okay, internal distance, or in the direction of the light, all those distances should be taken as a positive, because it is in the direction of the light. And the distance is measured in the opposite direction of the light. Okay, you are supposed to measure from the pole, from pole to that object. This distance should become as a negative, because in the opposite direction of the light, the distance should be considered as a negative. So this is what the second sign convention that we should use. Okay, and third sign convention says that the upward distances perpendicular to the principal axis are taken as positive, while the downward distances perpendicular to the principal axis are taken as negative. It is very simple. If you are measuring the distance above this principal axis or upward of the principal axis, and if they are perpendicular to this principal axis, those distances should be taken as a positive. And if you are measuring the downward distance perpendicular to the principal axis, those distances should be taken as a negative. Very simple rules are there. First point says that all the distances should be measured from the pole. First sign convention. Second sign convention says that the distances measured in the direction of the light, okay, in the direction of the light, they are taken as positive, and the distances measured in the opposite direction of the light, those distances should be taken as a negative. And third point says that the distances, upward distances, okay, on the principal axis, perpendicular to the principal axis, those distances should be taken as a positive, and the downward distances perpendicular to the principal axis, they should be taken as a negative. Okay, I will tell you a simple example. If you imagine it as a simple concave mirror, okay, and there is an object here, okay, imagine the object here, the distances should be measured from this pole, the first point, and distances measured, okay, in the direction of the light is coming from this direction, okay, from this point to this point, these distances should be taken as a positive, and in the opposite direction of the light, they should be taken as a negative. Okay, suppose this pen is about 10 cm from a concave mirror, this 10 cm should be negative form, minus 10 cm, because it should be measured in the opposite direction of the light, and it should be in negative line. So that's why opposite to the incident line, that should be taken as a negative. And the upward distances, okay, above this principal axis height, that should be taken as positive, and below the principal axis,